Alright, so here's a video I told you guys in class that you were going to have to watch tonight. This is Light by Mr. Reynolds. And here's kind of a question, right? Hey kids, do you see a light? Why and how? And those are some of the questions that we are hopefully going to answer as we go through this today. Alright, so first thing we have to answer is what is light? And we've discussed this a little bit in class, but hopefully through this little mini lesson, it'll help you guys to understand what light is a little bit clearer. So in this PowerPoint presentation, we're going to look at the properties of light, colors, reflection, and refraction. So the properties of light. Light travels in straight lines. So just like with a laser pen, light travels straight. Even with a flashlight, you'll notice that it doesn't bend or move around any corners. Light travels much faster than sound. For example, thunder and lightning start at the same time, but we see the lightning first. When a starting pistol is fired, we see the smoke first and then hear the bang. So those are a couple examples of how light travels much faster than sound. Light travels very fast, if you haven't already realized that, about 300,000 kilometers per second, or roughly 186,000 miles per second. At this speed, light could travel the equivalent of 8 times around the world in 1 second. Light can create shadows. Shadows are places where the light is quote-unquote blocked. So for example, you see the rays of light hitting the tree, and you get a shadow. This area is where the light was blocked. That's how shadows are created. Light also travels in waves. A wave is a disturbance that transfers energy from place to place. So you can see light waves are like any other kind of waves. They have crests, fur-offs, wavelength, frequency, and speed. However, light waves are electromagnetic. Light waves have a component that is electric and magnetic, and we'll talk about that a little bit. We see things because they reflect light into our eyes. This is literally the only way we get to see things. If we didn't have any reflection, we wouldn't see things. All objects we see either create light or reflect light, just as you see. Light is a form of energy called electromagnetic radiation. Electromagnetic radiation comes from the sun and other sources, like a lamp, a fire, a kerosene lamp, lightning, a flashlight, light bulb, and many other sources that aren't pictured here. Sorry about that. Electromagnetic radiation travels at the speed of light, mostly invisible, carries energy, and is quote-unquote very important to society, and sometimes you can't be without it for many reasons. So you see like x-rays, telephone signals, radio signals, microwaves, many other ones that you can see right there. So some types of electromagnetic radiation, right? Radio and TV, great for broadcasting. Microwave waves, super for cell phones and microwaves, of course. Infrared, think heat, right? Infrared lighting, the military uses quite a bit. Then we have visible light. This is how we see. Ultraviolet, which is invisible and sometimes can cause cancer and kill germs. X-rays, right? We wouldn't know what to do without that because that tells us, we can see our bones and teeth. We can also look at space exploration with that. And then gamma rays, if you've ever known anybody that's had to have radiation therapy. Gamma rays are the electromagnetic radiation that they are actually going under for treating cancer. Some properties of light summary. Light travels in a straight line and is a form of energy. Light travels very fast. We see things because they reflect light into our eyes, and shadows are formed when light is blocked by an object. Visible light is only a small part of that spectrum. The other parts are visible to the human eye, but not necessarily the eyes of other animals. Part 2. Excuse me. Reflection and mirrors. So regular versus diffuse reflection. So we have smooth, shiny surfaces have regular reflection, right? Just as you can see right there. Rough, dull surfaces have what we call diffuse reflection. Diffuse reflection is when light is scattered in different directions. So just like you can see, right, the light hits that and it may be reflected in a number of different ways depending on what surface it hits and the characteristics of that surface. So using mirrors, two examples. Right, this is kind of like a periscope, right, where you have light being reflected off the boat, reflected off one mirror, down to another, and down to the person looking, like a periscope. A car headlight is just like that as well. You have the headlight giving off beams, right, off the back of the car headlight and then shining back out. So two types of mirrors. We have a plane, a concave, and a convex. Plane mirrors are flat and make virtual images. The image is virtual because the light rays do not come from the image. They only appear to. So it's kind of like the bathroom mirror. You look at it and it gets reflected off of. You're not actually looking at the actual image. You're looking at an apparent source. Concave mirrors are curved inward. Right, so let's go back to that one real quick. Just remember you go into a cave and into a concave mirror. That's one way of remembering it. Convex mirrors are mirrors that are curved outwards. Convex mirrors are used for security purposes in cars, etc. They allow us to see a wide view, so just like your parents' rearview mirror. So review of reflection real quick. We have two types of reflection, regular and diffuse. Mirrors come in three types, convex, concave, and plane, and each has a distinct shape and use. Mirrors can make virtual images or real images depending on their type. Virtual images, light rays do not meet in the images always upright or right side up. And lastly, real images, always upside down and are formed when light rays actually meet. Refraction. That's when waves speed up or slow down due to traveling in a different medium or source. A medium is something that light waves will travel through. Light rays are slowed down by the water, causes the ruler to look bent at the surface. The mediums or sources in this example are water and air. The degree that light bends when it enters a new medium is called the index of refraction. You're not really going to have to remember index of refraction, but it's good to know. Light hitting at an angle is bent, as you can see from this picture. Light hitting straight on is not bent. Lenses work because of refraction. Light is bent as it enters a new medium, glass. So we have convex lenses, which again, they are thicker in the middle, thin on the edges. Light rays meet to form a focal point. Makes real images since light rays come together, but can make virtual images. They're used in cameras, telescopes. The human eye is one of them. Concave lenses are thin in the middle, thicker on the edges. Since light rays never meet with this lens, they make virtual images only. They're used in telescopes to correct the way something looks. They're also used in eyeglasses and cameras. Okay, so a quick review of refraction. Light rays slow down when they enter something new, like a new medium. Refraction can cause light rays to change their direction. All transparent materials have their own index of refraction. Light is refracted when it passes through lenses and creates images. And color. We'll be going over color a little bit in class, but as for now, what I need you to remember for your quiz tomorrow is refraction, reflection, and how light travels. So if you can, go back, review some of those, maybe take some quick notes. I'll let you use your notes on the quiz tomorrow. So if you can, go back through those and check those out. I hope you enjoyed the video, and good luck on your quizzes tomorrow.